Student, I am going to discuss a problem of elasticity. The problem is a ring of radius r made of lead wire of breaking distance sigma and density delta is rotated about a stationary vertical axis passing through the center and perpendicular to the plane of the ring. Calculate the number of rotation at which the ring rupture. Okay. Here you have a ring of radius r which is rotating about the center mass axis. Let omega is the angular velocity. Okay. Then you take the element of the ring of angle theta. So the tension at the free end of this element T and T, and let A is the area of cross section of here. Okay. Now you extend the T in backward direction and this also in backward direction, and so it makes angle theta by 2 and this is also theta by 2. Okay. Now first we have to find the mass of this element again. So mass of the element dm is equal to density into volume of the element. Here the density is delta and volume is, the length of it is r theta, and area, the area of cross section, so it is r theta into a. Okay, so it will be this delta a r theta. Okay, and now the net force of T, here it is one component along the center of the ring, that is T sin theta by 2, and here also the T sin theta by 2, so it becomes 2T sin theta by 2, and the component in this direction T cos theta by 2, and here is also T cos theta by 2. These get cancelled out, so net centripetal force becomes 2T sin theta by 2. So using Newton's second law, we have the centripetal force, that is 2T sin theta by 2 is equal to dm omega square r. Okay. Now we put the value of dm from this above equation. This is delta a r theta omega square r, and for a small angle this sin theta become theta by sin theta by 2 become theta by 2 only, so it is 2t into theta by 2. So here it is 2 which is 2 and theta get cancelled out from both sides, so t is equal to, this is delta a r square omega square. Okay. Now so the stress in the wire, stress F is equal to T upon area of cross section, so it will be delta a r square omega square upon a. So A get cancelled out, it will equals to delta r square omega square. Okay. Now as you have given, the breaking strength is equal to sigma, so the breaking strength, this will be equals to the stress in the wire. So put here sigma instead of F, so sigma is equal to delta r square omega square. Okay, we solve it for omega, we have under root sigma upon delta r square. Okay, if n be the number of rotation, so we can write n is equal to omega upon 2 pi, so it will be 1 upon 2 pi under root sigma upon delta r square. Okay.